Hello, myself Dr. J D Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss regarding modularity, a design concept which can be used in the designing of software architecture. This topic learning outcome is mapped with the course learning outcome of CO4, which is understand the importance and need of design and explain the various approaches of designs. In this video, I will discuss regarding what is software design, how the design concepts can be implemented, what is the design process and the importance of modularity, and what are various approaches of the modularity. So first of all, we have to discuss regarding the software design. Software design is a mechanism to transform user requirements into some suitable form, which helps the programmer in software coding and implementation. So during the analysis phase, the requirements can be gathered and those can be requirement engineering techniques can be applied, analyzed, so that the requirements must be documented in a document called SRS, Software Requirement Specification. So during the software design, the client's requirements that are described in this SRS is converted into easily implementable form using the programming language. So that is software design visually models the features of the application under development. In software design, the system is considered to be a set of components, modules with clearly defined behavior or boundaries. So the project is divided into small manageable components and those components can be easily implemented by using software engineers in the coding phase. Generally, two levels of software design can be available. One is the external design, second one is the internal design. The external design focus on the user interactions. So how the stakeholders can interact with the system and how easily they can access the system functionalities. Next, the internal design focus on the planning and providing the required resources and defining the internal structure and processing details are clearly mentioned in internal design. So the design concepts that are considered during software design are generally the abstraction. So the design details must be produced, only the required details, by hiding how to implement them. And information hiding, how the data sharing between the components can be possible and can be restricted through access specifiers is clearly mentioned in case of information hiding. The refactoring, so making a small change which will produce and increase the performance or application aesthetic properties is generally referred as refactoring. The modularity basically used to divide the project into small manageable components. So the functional dependencies can be concentrated with the separation of concern principle. The pattern refinement, these design patterns provide the template for implementation. The architecture provides the blueprint or structure of the system. Refinement is used to refine or modify the design so that the changes can be considered and dependencies can be greatly reduced. The separation of concern is the basic design principle. In this, the design concept that suggests that any complex problem can be more easily handled if it is subdivided into pieces that can each be solved and are optimized independently. So, a concern is a feature or behavior that is specified as part of the requirements model for the software. So, by separating concerns into smaller, therefore more manageable pieces, or a problem takes less effort and time to solve. So, the architecture of the software system is the complete structure of the software, generally referred as software architecture. This architecture, the structure of program modules where they interact with each other in a specialized way. So, the aim of software design is to obtain an architectural framework of a system. But the information hiding is one more design concept. There the modules must be specified and designed so that the information like algorithm data presented in the module is not accessible for other modules, not requiring that information. So, the information or the data, important data can be prevented for accessing other components of the architecture. This can be achieved with the help of access specifiers of the programming language. Hiding implies that effective modularity can be achieved by defining a set of independent modules that communicate each other. Only that information necessary to achieve the software function is shared between the modules in the architecture. So, modularity is a design principle which can be a software is separately divided into name and addressable components. So, sometimes they are called the modules which integrate to satisfy the problem requirements. When these modules are integrated, the system or project can be formed. Modularity is the single attribute of the software that permit a program to be managed very easily. So, modular design is an approach for product designing which is used to produce a complete product by integrating smaller parts that are independent of each other. So, with the modular design approach, a complex product can be broken down into smaller parts and simpler components that are independently designed and manufactured. For example, consider a car. So, the independent components like seat, brakes, all are generally manufactured independently and are integrated to form the architecture of the car. So, like this, in the project also, the project can be divided into small manageable components so that they can easily develop and integrate to solve a problem. So, each of these individual components is then integrated together to form the final product. So, the benefits of the modular design is easier to add and maintain smaller component, easier to understand each module and their purpose, easier to reuse and refactor modules, better abstraction between the modules, saves time needed to develop, debug, test and deploy a program, and reusability is the major concern for the modular design. So, what is modularization? Is the process of separating the functionality of a program into independent interchangeable module such that each module contains everything necessary to execute only one aspect and of the desired functionality. So here consider this is the control module which can control the other component 3 modules like the submodule, library modules. So to control the independent components. These components can be independently developed and these 3 are integrated to form the control module. So while designing the modularization, majorly the modular design considers 2 approaches. One is top-down design, second one is bottom-up design. So in the top-down modular design, the software engineering technique, it is the one of the software engineering technique that involves starting with high-level overview of a system and then breaking it down into smaller, more manageable parts. So the top or the high-level component must be first considered and that must be broken down into small manageable parts. It generally involves 3 phases. One is start with high-level overview. Second one, break down into sub-problems. Third one, continue until simple enough. So, in the start with high-level overview, define the main modules and the overall problem. In the step of breakdown into sub-problems, systematically divide the system into smaller, more manageable sub-components. In the third step, continue until simple enough. Continue this process until each subcomponent is simple enough and can be efficiently implemented and tested. So this is the approach of the top-down modular design. So the top module is considered first, which can be divided into sub-modules. Here the top module is divided into 2 sub-modules, sub-module 1 and sub-module 2. Sub-module 1 again divided into sub-module 1.1, 1.2. Sub-module 2 is divided into sub-module 2.1 and sub-module 2.2. So, these independent components, when they are integrated, sub-module 2.1, 2.2, if integrated, then sub-module 2 can be formed. So, this process can be continued until no further division is possible. All simple components can be defined. So, the benefits of the top-down design is it can help to ensure that software architecture is robust and scalable, and it can also make projects more manageable, faster to complete, higher quality, easier to debug, and promote code reusability. So, top-down design is often visualized as a tree structure with the root representing the main system or problem and the branches representing progressively smaller and more detailed parts. So, in this approach, this represents the tree structure. The root can be the top module and the branches can be the manageable submodules. Next, second approach in the modular design is the bottom-up modular design. In software engineering, bottom-up module design is a strategy that starts with the details of systems components and builds up to a complete system. So, the steps in the bottom-up module design are generally start with details, link elements, repeat, test. So, start with the details step, focus on, begin by specifying the system's individual base elements in detail. In the second step, connect these base elements to form larger subsystem. Repeat step involves continuing linking subsystems until complete system is formed. Test is used to build and test each module individually before integrating them. So this is the bottom-up approach. In this, first the submodules or subcomponents can be implemented, tested in detail. So these subcomponents can be in the next step integrating up to form the submodules. For example, submodule 1.1, submodule 1.2 are integrated to form the submodule 1. And submodule 2.1, submodule 2.2 are integrated to form the submodule 2. Submodule 1 and 2 can be integrated to form the top module. So the integration can be carried out in a upscaling fashion in the bottom-up modular design. So the benefits of bottom-up design approach is used when the system need to be created from existing components. It's a traditional method that emphasizes code reusability, and the development of individual components can be easily integrated. So bottom-up design is different from the top-down approach, which starts with a broad view and then works its way down. So to design effective module, a module can be defined first as a unique and addressable component of the software which can be solved and modified independently without disturbing or affecting other modules of the software. So functional dependencies between modules are greatly minimized. Effective modular design can be achieved if the partitioned modules are separately solvable, modifiable as well as compatible. So here a separate compatible modules means that after making changes in a module, there is no need of recompiling and the whole software system. So the dependencies of data sharing and functionality sharing is greatly minimized. Then only the module designing can be effective. So what is functional independence? So functional independence is the concept of separation and related to the concept of modularity, abstraction and information hiding. So independent modules are easier to maintain because secondary effects caused by design or code modifications are limited. Error propagation is greatly reduced. So the functional dependency is accessed using two criteria, coupling and cohesion. What is coupling and cohesion? So here this is the module 1 and this is the module 2. The module 1 providing three functions, function 1, function 2, function 3. Module 2 is also producing three functionalities. So if module 1 is achieving its functionality in association or depending on module 2, then the degree how it can be dependent is generally referred as the coupling, and the independently the degree that can be single-mindedness to achieve the functionality is generally referred as cohesion. So cohesion is measure of the degree to which elements of the module are functionally related. So a cohesive module performs a single task and it requires small interaction with other components and the other part of the program. So cohesion is internal glue that keeps the module together. A good software design will be high cohesion. Variety of cohesions are available. Basically, they are coincidental cohesion, logical cohesion, temporal cohesion, procedural cohesion, communicational cohesion, sequential cohesion, functional cohesion. The coincidental cohesion is when part of the module are grouped arbitrarily, then only relationship between the parties they have been grouped together. So, for grouping of the modules or part, then the functionalities are grouped together. Only that relationship exists between the functional dependency between the modules, and elements contribute to activate with no meaningful relation to one to another. Only grouping or classification are the major motto, and there is no meaningful relationship between the modules that are grouped. Similar to logical cohesion, except activities may not be the same type. So difficult to understand and maintain, with strong possibilities of causing side effects every time the module must be modified. The second one is logical cohesion. In the logical cohesion is when parts of a module are grouped because they are logically categorized. So some logical relationship exists between the components that can be classified. For example, grouping all mouse and keyboard input handling routines. Temporal cohesion. Temporal cohesion is when part of a module are grouped when they are processed. So the parts are processed at a particular time in a program execution. So depending upon the time, the cohesion can be take place. That's why it is referred as temporal cohesion. Next one is procedural cohesion. Procedural cohesion is when parts of a module are grouped because they always follow a certain sequence of execution commonly found at the top of hierarchy, such as the main program. So control modules can be generally used for procedural cohesion. This cohesion is similar to sequential cohesion except that elements are unrelated. So module is to possess procedural cohesion if the set of functions in the module are all part of the procedure or algorithm in which certain sequence of steps have to be carried out for achieving an objective. Next variety of cohesion is communicational cohesion. A module is said to be communicational cohesion if all functions of the module refer to or update the same data structure. So, elements contribute to activities that use the same input-output data. Not flexible. For example, there is a need to focus on some activities and not the others. Then possible links that cause activities to affect each other. Better to split to functional cohesion ones. Sequential cohesion is when the part of the module are grouped because the output from one part is the input to another part, like an assembly line. A function which reads data from a file and processes the data. So usually has good coupling and is easily maintained, but not so readily reusable because activities that will not generate useful together. Functional cohesion is when the part of the module are grouped because all contribute to a single well-defined task for a module. So, some computational capability or the function to be released, then those modules can be grouped. Example, lexical analysis of a XML string. So, it can be this cohesion can be focused, strong, single-minded purpose, and no elements are doing unrelated activities. Only the motto is the defined functionality must be provided. The another term that can be greatly impact the functional independence is the coupling. Coupling is an indication of interconnection between the modules in a structure of the software. So, in the architecture, These coupling plays the major role. A good software will have low coupling. And the major types of coupling are data coupling, stamp coupling, control coupling, common coupling, content coupling. What is data coupling? Data coupling occurs between two modules when the data are passed by parameters using simple argument list. Every item in the list can be used. So during the function calls in the programming language, data coupling can be used. For example, retrieve the customer info. So retrieve the customer address. So this item can be passed and can be shared customer ID and customer address between the called function and the calling function. So this is the data coupling. The another variety of coupling is the stamp coupling. Stamp coupling occurs between modules when data are passed by parameter using the data structure containing fields which may or may not be used. But in case of data coupling, all arguments must be used. In case of stamp coupling, only the required data structure elements can be used. So here only it can take the customer details in order to retrieve the customer address. The another variety of coupling is the control coupling. Control coupling occurs between modules when data are passed that influence the internal logic of the module. Example, the flag elements or the switches are the best example of control coupling. So here the customer ID, customer name must be data shared between the modules. But info type, which information type it must be represented, is used as the flag for the control coupling. Common coupling is the next variety which occurs when modules communicating using global areas or data. So universal common data areas or the global areas or variables are generally used for common coupling. For example, C allows the developer to declare a data elements as external, enabling it to access by all modules. So with the type specifier, storage class specifier, extern in the C programming language is used to declare the data so that it can be accessed by all modules. So common coupling is also known as global coupling. Next variety is the content coupling. Content coupling occurs between two modules if one refers to the internal of the other module. For example, if one module branches to another module, if one module refers to or changes data in other module, if one module alters a statement in another module. So, one module is modifying the content or functionality of other module. Then this is the best example of the content coupling. In practice, only assembler language allows to modify the content coupling. So the other design concepts that can greatly affect the modularity is the refinement. Refinement is a top-down design approach. It is a process of elaboration. So a program is established for refining levels of procedural details. A hierarchy is established by decomposing a statement of function in a stepwise manner till the programming language statements are reached. The next design concept principle used in the modularity is refactoring. It is recognition techniques which simplifies the design of component without changing its functional behavior. So that refactoring is the process of changing the software system in a way It does not change the external behavior of the code, still improves its internal structure. So in this video, I discussed regarding what is the design, what are the software design levels, and how the modularity and architecture are greatly influenced during the problem solving, and in how to achieve the functional independence while designing the modularization process. What are the approaches and the two basic parameters of coupling and cohesion, how refining and refactoring can affect the modularity is discussed in this video, and the references used in this video are this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.